Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and within this video we are going to solve a GATE question. So this question was asked in the year 2004 for 2 marks, and this question is basically related to the fork system call. So let's read this question. So the question says that a process executes the following segment of code, right? So this is the code segment that this question is referring to. So what is happening in this code? It's a very simple for loop, and as you can see, it is going from 1 up till n. So this loop is iterating for a total of n times, right? You can see n is inclusive, and the only statement that is being executed in this for loop is the fork system call, right? Now the question asks that the number of new processes created is, and your options are given as follows. So basically you have to quantify the number of new processes, right? New is the key term here. You have to quantify the number of new processes in terms of n, right? So let's see how to proceed with this question. So the very first thing is that let us recall what does the fork system call do, right? As we have already discussed in one of the earlier videos, the fork system call is used for process creation. And let me quickly go over the system call. So as you can see, the fork system call creates a new process by making a copy of the original process. You can say it duplicates the original process. So here in this example, you can see this is process A, and process A invokes the fork system call, right? When it does that, the control is transferred to the operating system. Basically, whenever you make a system call, the control is transferred to the appropriate routine within the operating system. So here is the fork routine inside the code of operating system. And what does the fork system call do? It creates a new process. You can see that is process B, and process B is identical to process A, right? It is almost an exact copy of process A, right? So you can see a new process has been created, and when the fork system call is done, when this routine is done, it returns twice, once in the parent process and another in the child process. So this is how the fork system call behaves at a very high level. We have discussed about this in great detail in the earlier video, right? So now let us get back to the question. So the question is basically asking that if a process executes this piece of code, then how many new processes will be created, right? So let's assume that this is our process, right? And here we are maintaining some values. So n is, we'll take some example values of n, right? Let's take the value of n, then 2, n as 1, then 2, then 3 and 4, and so on. And we'll see how does the number of child processes vary with the value of n, right? So let's assume that the number of that the value of n is 1, right? So how many times will this loop run? It will run for one time, right? Which means that within the parent process, this is the parent process, right? Within the parent process, this loop will run for one time, and it will invoke the fork system call, and it will create a child process, right? And once this is done, the fork system call will return, and when it returns, basically now the next statement that will be executed in the child process will be that of incrementing the value of I. So value of I will become 2, and the process, the child process, both in the child as well as the parent process, the loop will exit, right? And no more fork system call will be executed. So if the value of n is 1, then only one child process is created. So the number of new processes is basically the same as the number of child processes, which I have highlighted in this dark blue color, right? So in this case, the number of new processes that are created is 1, right? So let me again summarize what happened here. When the parent process invoke the fork system call, the execution is after the execution. When it returns, it will be here after the fork system call in both the parent and the child, and then it will go to here, increment the I value of I, which was 1. Now it will become 2, and it will exit. So no more fork system calls will be executed. This part is crucial, because why no new processes are created after this? Because in both the parent and the child, the for loop is will exit after the first fork system call, right? Now let's assume that the value of n is not 1, it's 2. What happens in that case? In that case, as you can see, in both the parent and the child, after returning from the fork system call, the value of I will be incremented to 2, and 2 is still less than n, which is, we are assuming that the value of n is 2 now, okay? So in that case, the for loop will not exit. It will execute this fork system call one more time. And when that happens, both the parent and the child process will invoke the fork system call. And as you can see, two new processes will be created. This parent again creates a child, and the first child process creates another child process. right? So the total number of new processes that have been created as part of this piece of code is now 3. There was our initial parent process. If we exclude that, then the number of new processes or child processes is 3, right? This was the initial process, and now we have 3 more new processes in the system. This happens when the value of n is equal to 2, right? Now let's see what happens when all of these processes return from the second fork system call, right? The first one has happened. Now the second fork system call is also done. And in all of these processes, execution will now return to this point where we increment the value of I. Again, the value of I will become 3, and 3 is not now less than 2. Basically 3 is now greater than 2, and in all of these 4 processes the for loop will exit, right? This happens when the value of n is equals to 2, right? Previously we talked about the value of n is equals to 1. There the for loop exited when the value of like became 2. But if the value of n is 2, the for loop will exit when the value of I is 3, right? In the same way, now let's assume what will happen if the value of n is 3. Now you can recognize the pattern here. If the value of n is 3, then instead of exiting this for loop, all of these 4 processes will return from the second invocation of the fork system call. They will increment this value of I. Value of I will be 3, right? And 3, now we are assuming that the value of n is 3. So 3 will still be less than equal to 3, and all of these 4 processes will invoke the fork system call, right? This is the third invocation, right? So when that happens, you can see all of this processes will create child processes. So the total number of processes in the system will be 8. And out of those 8 processes, if we exclude the initial parent process, then the number of child processes is 7. So you can see the number of child processes is doubling with every as we increase the value of n. As the number of fork system calls we are increasing, the number of child processes, basically the total number of processes is doubling in the system. We started with you can see when the value of n was 1, the total number of processes in the system was 2, right? And the number of child processes was 1 less than 2, which is 1, right? Then if we had the value of n is 2, the total number of processes doubled. It became 4 from 2. Similarly, if we had n is equals to 3, it again doubled. It became 8 from 4. And as you can see this trend, if we make the value of n as 4, this value will again double, right? The total number of processes in the system will be 16, and the number of new processes, the number of child processes will be 1 less than 16 if we exclude the parent process. So the total number of child processes will be 15. So as you can see, this is a pattern, right? We can derive a formula from this. So as you can see in this table, depending on the value of n, the number of child processes, it follows a it is directly proportional to the number of the value of n. And how is this number related? For 1, we had number of child processes as 2 to the power 1 minus 1, which is 1. For 2, we have 2 to the power 2, which is 4 minus 1, 3, and so on, right? So you can see there is a formula that we can derive from this. If there are n calls to fork, the number of child processes is 2 raised to the power n minus 1, right? So this 2 raised to n, why is this coming? This is coming because with every increasing value of n, the total number of processes in the system is doubling, right? For n is equals to 1, the total number of processes in the system was 2. For n is equals to 2, it was 4. For n is equals to 3, it was 8. And for n is equals to 4, it was 16, right? So this is the total number of processes in the system. And if we exclude the parent process, right, we have one parent process, then that gives us the number of new processes or the number of child processes that were created as part of executing this piece of code. So if there are n calls to fork, right, in the code, right, if you write a piece of code which has n calls to fork, here we were calling the fork in a loop, right, basically. But if we unroll the loop, right, that piece of code, that initial piece of code that we saw, here you are calling the fork system call n times, right? Then the number of child processes is given by this formula, that is 2 to the power n minus 1. And let's also confirm this via a demo. Basically, let's execute this piece of code and confirm this. So let's come to the piece of code. So here is this simple C code that I will execute, and you'll see that whatever we just saw is valid. So I have modified this code a bit. This part is the same. This for loop is taken from the question only, but I have introduced some logic before and after to print some messages. So I'm assuming some value of n. Here I have taken n is equals to 4, right? And for n is equals to 4, if you remember, the number of child processes was 15, right? The total number of processes will be 16 and the number of child processes will be 15. So what I'm doing is that first of all, I'm storing the value of parent process ID by calling this get PID system call. Once this is done, we start the fork system. We start this loop, and we will have the fork system call be invoked multiple times. New child processes will be created, right? But in all of them, this parent PID will be same, right? We have already stored this in this parent PID variable, and whenever the processes invoke the fork system call, whenever new processes are created, they will have this copy of parent PID variable which has the same value, right? And finally, in each process, what I'm doing, I'm getting the PID of the current process and comparing it with the parent PID that I have already stored. If it is equal to the parent PID, then I am printing parent and the PID. Otherwise, I'm printing child. So this is basically trying to distinguish. Basically, it's just figuring out the PID of the current process, and it is matching with the PID of the parent process that we have already stored. If we are actually executing inside the parent, we will print parent. Otherwise, we will print child. So it is just to distinguish between the different processes in the system. So let's execute this piece of code. Uh, so I have already compiled this piece of code. It is as a.out. Let me go ahead and execute. So as you can see, here we have multiple statements printed. 13,499 is the PID of the parent, and after this, child process has been this statement child has been printed 15 times. Like right from here up till here, 5, 5, 5, 15. So 15 child processes were created, and if you see the PIDs, it starts from 13,499 and it goes up till 13,000. So my point is, all of this are unique. All the PIDs that you see here, they are unique. None of these PIDs are same. It goes up till 13,514, right? You can verify. The parent process ID is 13,499 and new processes are created and the PIDs go up till 13,540, right? So this verifies what we just saw, that if we have this fork system call and if it is executed 4 times in an iteration, in the piece of the like the parent process, the code of the parent process has this fork system call, and here the value of n is 4, then the number of child processes is 2 to the power 4 minus 1, which is 16 minus 1, that is 15. Let's change the value of 4 and verify again. Let me make this 2. So what will be the number of child processes that is created? It will be 2 raised to the power 2, which is 4. 4 minus 1, 3. So let me compile this. GCC fork underscore child dot c, right? And we again execute this. So you can see the formula that we just derived, it holds true. The number of child processes that have been created is 3. The parent process has this PID of 13,779. You can see 780, 781 and 782. 3 child processes were created, right? So this validates what we just discussed. That is, if there are n calls to fork in the code of the parent process, right, then the number of child processes will be 2 raised to the power n minus 1. So let me clarify this statement. If there are n calls to fork, in total, the number of invocations, the total number of invocations in the system will be 2 raised to the power n minus 1, right? That is why the number of child processes is 2 raised to the power n minus 1. But in the code, there are n fork statements, right? In the piece of code that we saw, there was a for loop which was running for n times, and in every loop iteration it was executing, it was invoking the fork system call. So if you see the code, then there are n invocations, n calls to the fork. This is in the code. So n here is basically the number of times fork has been written in the code, right? But the total number of invocations that will happen, if you see all of the child processes that are being created, they will also call the fork system call. In total, the number of invocations or the number of child processes that will be created, that is 2 raised to the power n minus 1. So n is the number of fork system call in the code, the number of times you have written fork in the code, right? Since it was a for loop, we had written it only once and made it a for loop. So n is the number of times the fork system call has been written in the code, and 2 to the power n minus 1 is the total number of invocations that will happen, because parent will create child will create further children, right? So the total number of invocations will be different. So this is the answer to this question. So we already have an option, that is option C. So the number of new processes created is 2 raised to the power n minus 1. So guys, this was it for this question. Here we had a piece of code, and in the piece of code, you can see if I don't have this loop, we can have n fork statements. So basically, if you are given any code which has n fork statements, right, this is basically equivalent to having n fork statements if you do not have the loop, right? If you do not have the loop, this code is equivalent to n fork statements. So if you have n fork statements, then the total number of child processes that will be created will be 2 to the power n minus 1. Or you can also say the total number of times the fork system call will be invoked is 2 raised to the power n minus 1, right? So this was it for this video, right? So thank you very much for watching this video, and I will see you in the next video. Thank you.